Hello, welcome to this session. My name is Kyani. I'm an authorized trainer for Google. I travel around the world delivering training to Google's clients and partners. In the next few minutes, we're going to explore Istio traffic management, resiliency, and telemetry features using a sample application called Book Info. The first thing we're going to do is download the latest supported version of Istio. That is version 1.4.5. Having downloaded Istio, we're going to enable APIs to services on the Google Cloud Platform, which we're going to use during this demo. Next, we're going to create a 2-node Kubernetes cluster in the US. With the cluster created, we're going to move on and retrieve the credentials to the cluster. Having retrieved the credentials, we're going to make sure the current user has admin privileges against the cluster. Before we move on to the next step, why don't we take a look at the cluster on the console? I'm going to navigate to the Google Cloud Platform console. Let's select Kubernetes Engine under the Compute section and select Clusters. The cluster is Book Info, located in the US region. The size is 2. It's a 2-node cluster. Currently has 8 vCPUs and 30 gigabytes of memory. We can view additional configuration information on the cluster by clicking on it. Under Details, we can see here the configuration of the cluster. At the bottom, we can see the node pool. There is one node pool. That is the default pool. It has 2 nodes. We can also view the configuration of the nodes by selecting the Node tab. In step number 4, we're going to install Istio, the service mesh. To do this, we're going to change into the directory for Istio. Next, we're going to create a namespace for the Istio components that will be installed in this cluster. We're going to use Helm to install Istio custom resource definitions. Let's make sure all of the custom resource definitions have been configured. Next, we're going to use Helm to install Istio. In doing this, we're going to select some optional components. Before we move on, let's go back to our Google Cloud Console and explore the configuration we've just made. We're going to move into the Workloads tab. Here you can see the Istio components being initialized. Let's refresh this view and everything appears to be running. Here we have a number of deployments configured in the Istio system namespace. We also have some jobs. We can select any of these deployments to view the dashboard with additional configuration information. This is the Overview tab. Here you can see some dashboards for CPU, memory, and disk utilization. Some additional configuration, including information on the pods that are provisioned using this deployment, as well as service endpoints and additional configuration relating to pod autoscaling. Let's take a look at services and ingress. Here we have all of the services and ingress that allows us to be able to access workloads running within the cluster. The Istio Ingress Gateway allows us to access workloads from outside of the cluster, while the cluster IP services enable workloads to be accessible from within the cluster. Let's take a look at configuration. Here we have a number of Istio-related configurations in the Istio system namespace, mostly secrets and config maps. We can also view a lot of these configurations using the object viewer. Let's select the filter, and here we can filter and select just the Istio related configurations. Let's apply this, and we can now expand on any of these and view configuration. Let's navigate back to the Kubernetes cluster landing page and back to our Cloud Shell console. With Istio installed and running, let's move on to the application domain. In step number 5, we're going to create a namespace for our application. We're going to call the namespace book info. Next, we're going to label this namespace for sidecar injection. Having configured the namespace, we're going to move on to the next step, step number 6. This is where we're going to configure the application service as well as deployment. And we're also going to configure a service account. Let's go ahead and do this. We're going to change into the directory where Istio was downloaded. We're then going to use the kubectl command in order to apply the YAML file that has the configuration for the service, the deployment, and the service account. In this YAML file, you can see that we have a number of services created and also deployments. Additionally, we have a service account for each of those services. In the next step, we're going to configure the gateway and virtual service. The gateway and virtual service is what enables us to be able to access the workloads that are running within the cluster from outside of the cluster. Let's select option 7. We're going to start off by changing into the directory where Istio was downloaded. Next, we're going to apply a YAML file that has the configuration for the gateway and virtual service. Having created the gateway and virtual service, we're going to save the IP address of the ingress into a variable. Next, we're going to modify the configuration of our gateway by specifying a fully qualified DNS. The value for the DNS is the IP address .xip.io. Let's take a look at the XIP website. XIP is a very useful utility for testing purposes. It allows you to specify a custom domain that resolves to an IP. In this example, any of these formats, that is ip.xip.io, resolves to the IP address, or anything in front of this also resolves to the IP address. For example, www.ipaddress.xip.io resolves to the IP address. Let's patch the book info gateway. In step number 8, we're going to inform the mesh of the different versions of the microservice that are running within the cluster. We do this by applying a destination rule that specifies the subsets as versions of the microservice. We're going to achieve this by applying a configuration file. This configuration file is within the samples directory for the book info application. We now have our application configured, as well as a gateway and virtual service that enables us to access the application. Before we move on to the next step, step number 9, where we're going to explore traffic routing, let's take a look at the configuration we've just made using the Google Cloud Console. On the Google Cloud Console, I'm going to navigate to Workloads. In the Workloads tab, I'm going to filter the namespace to the book info namespace. And in the book info namespace, you can see the deployments for the different versions of our microservice. We have 3 deployments configured with only one version, that is details, product page, and ratings. And for the reviews microservice, we have 3 deployments representing the 3 versions of the reviews microservice. Let's take a look at one of these deployments. I'm going to navigate to the pod that was created using this deployment. And you can see that this pod has 2 containers. This is the proxy container that was injected into the pod by virtue of the namespace being labeled for automatic Istio sidecar injection. And here we have the container running the application. I'm now going to move on to the Services tab. And here we can see the services that enable those pods to be accessible within the mesh. Let's take a look at the configurations we applied using the object browser. I'm going to add the application API group to the list. Let's expand the apps section. Here we can view the deployments. Let's have a look at networking. We previously configured some destination rules. Let's have a look at reviews. And here we have a destination rule specifying the versions of the reviews microservice. We can also view the gateway configuration. The gateway configuration specifies the domain we specified when configuring the gateway. The protocol is HTTP and the port is port 80. We can also view the virtual service configuration. The virtual service defines a number of URL paths. To access the front-end service, we need to specify a URL path of /product page. Before we move on, let's access the application. So I'm going to open a new tab. The virtual service URL was product page. Let's access that URL. And here you can see the application. I'm going to make this slightly bigger. So we have here the book info application. Let me refresh the browser. You can see this version is using the rating service without a star. That's version 1. This is the version with a star. and there is a version as well with a black star. So we have 3 versions of the rating service. Before we move on, let's have a look at our console and access one of the services that we configured as an add-on. That's Kyani. We're going to navigate to the bottom and enable port forwarding. To do that, we're going to copy this code. We're going to run it within Cloud Shell. So let's run the code within this Cloud Shell environment. Let's go back to our console. Let's open Kyani. Here we have Kyani. Let's have a look at the graphs. This is the book info namespace. Let's have a look at the workload graph. And let's display requests per second. And let's animate traffic. Let's hide this in order to make the topology more visible. Currently, you can see there's no traffic flowing within the mesh. Let's move on to step number 9. In step number 9, we're going to start off by generating some load. We're going to create an endless loop that invokes the product page URL once every second. Let's keep this running in the background. And before we move on, let's take a look at the Kyani dashboard to make sure there is traffic flowing through the mesh. So here you can see that there is traffic flowing through the mesh, and the traffic is flowing to all of the versions of the review microservice. Let's go back to our Cloud Shell console and carry on with our exploration of traffic shaping. Let's take a look at the first configuration file we're going to apply. This configuration routes traffic to version 1 of every microservice. Let's go ahead and apply this configuration and return to our Kyani dashboard to see what happens with the traffic flow. The configuration has now been applied. And now you can see that all of the traffic is flowing to version 1. There is no traffic flowing to the reviews microservice version 2 and version 3. Let's return to our console. We're going to delete this configuration. Let's delete the configuration. Having deleted the configuration, let's take a look at the Kyani dashboard. And you can see that the traffic is now flowing to all of the versions. Okay, let's return to our Cloud Shell environment. Let's view the next configuration we're going to apply. This virtual service configuration will essentially direct all traffic to version 3 except for a user JSON. So all incoming traffic from JSON will be forwarded to version 2. Otherwise, every single request will be to version 3. So let's go ahead and apply this configuration. Having applied the configuration, let's take a look at the console. That's the Kyani console. We should see all of the requests being forwarded to version 3 of the microservice. You can see on the screen confirmation of the fact that traffic is actually flowing to version 3 of the microservice. Let's go to our console for the application. Let's refresh this browser a few times. It doesn't matter how many times we refresh the browser, the traffic always flows to version 3 of the ratings microservice. That's the one with red stars. Before we log in as the user JSON, let's take a look at the Kyani dashboard, and you can see once more all of the requests are to version 3. Let's log in as the user JSON. And now you can see that for JSON, all of the requests are to the service with black stars. Let's return to our console. And you can see here confirmation of the traffic flowing to version 2. After a few minutes, we should be back to where we were before. And with no more requests from the user JSON, we're back to where we started off. Let's go back to our Cloud Shell console. Let's delete the rule. Let's take a look at the next configuration we're going to apply. We're going to split traffic between version 1 and version 3. However, before we do that, let's go back to the Kyani dashboard. You can see here that we're now back to the original position where traffic is flowing across all of the 3 versions. Let's return to our Cloud Shell console and apply this new virtual service configuration. Having applied the configuration, let's return to our Kyani dashboard and visualize the impact of this new configuration. We now have confirmation that traffic is being split equally between version 1 and version 3. Let's delete the current virtual service configuration. Let's examine the Kyani dashboard. We're now back to where we were with traffic flowing across all of the 3 versions. Let's move on to the next configuration. In this instance, we're going to route all of the traffic to version 3. Let's apply this configuration. Let's go to our dashboard and visualize the impact of applying this configuration. Finally, confirmation that 100% of the traffic is being routed to version 3 of the microservice. We're now going to delete this virtual service configuration. That concludes the exploration for traffic routing. Before we move on to exploring resiliency, let's have a look at our Kyani dashboard and make sure all of the traffic is flowing across the 3 microservices. And we can see that that indeed is the case. Let's carry on to option 10. In step number 10, we're going to generate some additional load in the background. Let's view the first configuration we're going to apply on the cluster. In this instance, we are routing all of the requests to version 1 of the microservice. For the user JSON, we're artificially simulating a network delay, that's a network latency of 7 seconds on 100% of the requests to version 1 of the ratings microservice. Let's go ahead and apply this YAML file. Once the YAML file is applied, we're going to view the Kyani Dashboard to make sure all of the traffic is being routed to version 1. Let's return to our application and log in as the user JSON. Let's sign in, and you can see that's a 7-second delay. Let's sign out. Sign in as a user JSON. And that's a 7 seconds delay. As a result of the 7 seconds delay, you can see that there is now an error. The error message says the product reviews are currently unavailable. This enables an operations team to be able to analyze the impact of network latency on the availability of services running within a cluster. Let's sign out. Let's return to the Cloud Shell console and delete this virtual service configuration. Let's view the next configuration. Once this configuration is applied, we're going to simulate an error code of 500 for all requests from the user JSON to the ratings service. Let's apply this configuration. Let's return to our console. Let's refresh our browser, and the application is working just fine. Let's log in as the user JSON. You can see a message here that says rating service is currently unavailable. This demonstrates that the microservices have been implemented correctly by displaying a friendly error message when the rating service isn't accessible. Let's sign out as the user JSON, and you can see for every other user, the rating service is indeed accessible. Cloud Shell console. Let's delete this virtual service configuration. In the next step, we're going to apply a new virtual service configuration against the ratings microservice. This configuration will artificially inject a 2 seconds delay, in other words, a 2 seconds latency on 100% of the requests to version 1 of the ratings microservice. Let's apply this configuration. Let's return to our application console. Let's refresh the browser. You can see the 2 seconds delay there. Refresh the browser and you can see a delay of about 2 seconds. So let's log in as the user JSON. Let's refresh the browser and you can see a delay of 2 seconds for JSON as well. Let's return to our Cloud Shell console and delete this configuration. This concludes the exploration of traffic routing and resiliency on the Google Cloud Platform using the Istio service mesh. Thanks for watching and have a nice day.